@NCERT video welcomes you. Today we are going to start Chapter 9 Symmetry. Let's start Chapter 9 Symmetry. Look around you. You may find many objects that catch your attention. Some such things are shown below: flower, butterfly, rangoli, pinwheel. There is something beautiful about the pictures above. The flower looks the same from many different angles. What about the butterfly? No doubt, the colors are very attractive. But what else about the butterfly appeals to you? In these pictures, it appears that some part of the figure are repeated, and these repetitions seem to occur in a definite pattern. Can you see what repeats in the beautiful Rangoli figure? You can see some parts repeat itself. Similarly, in butterfly, you can see this half is mirror image of the other half. Similarly, in the Rangoli, this half is same as this half, or this half same as this half. Similarly, about this line. If you see the Rangoli carefully, you can see these portions are similar to each other. In the Rangoli, the red petals come back onto themselves when the flower is rotated by 90 degrees around the center, and so do the other parts of the Rangoli. What about the pinwheel? Can you spot which pattern is repeating? Hint: look at the hexagon first. You can see a hexagon in the center. Structures on the hexagon are repeating itself. In a hexagon, each side subtend 60 degrees at the center. You can see here. You can see this half is same as this half. Similarly, along this line, this half is same as this half. Similarly, there are other lines too. If you rotate the pinwheel by 60 degree, 120 degree, 180 degree, 240 degree, 300 degree, or 360 degree, you will see same pinwheel is reappearing onto itself. Now, can you say what figure repeats along each side of the hexagon? What is the shape of the figure that is stuck to each side? Do you recognize it? How do these shapes move as you move along the boundary of the hexagon? What about the other pictures? What is it about those structures that appeals to you, and what is the pattern in those structures that repeat. On the other hand, look at this picture of clouds. There is no such repetitive pattern. We can say that the first four figures are symmetrical and the last one is not symmetrical. A symmetry refers to a part or parts of a figure that are repeated in some definite pattern. You can see a symmetry in Taj Mahal about this line. Similarly, you can see symmetry in Gopuram about this line. What are the symmetries that you see in these beautiful structures? You can see this left portion is mirror image of this right portion. Similarly, in this too. 9.1 Line of Symmetry. Figure A shows the pictures of a blue triangle with a dotted line. What if you fold the triangle along the dotted line? Yes, one half of the triangle covers the other half completely. These are called mirror halves. You can see when you fold the triangle along this line, you will see this portion is exactly overlapping this portion. Or you can say this portion is mirror image of this portion, or these two portions are mirror halves. What about figure B with the four puzzle pieces and a dotted line passing through the middle? Are they mirror halves? No. When we fold along the line, the left half does not exactly fit over the right half. You can see here. This portion or this portion will not fit onto this portion. A line that cuts a figure into two parts that exactly overlap when folded along that line is called a line of symmetry of the figure. So you can say this is line of symmetry. Figure it out. 1. Do you see any line of symmetry in the figure at the start of the chapter? What about in the picture of the cloud? 2. For each of the following figures, identify the lines of symmetry if it exists. This is a line of symmetry. Similarly, this one. In this, there is no line of symmetry. And in this one is line of symmetry. In this, no line of symmetry. Figure with more than one line of symmetry. Does a square have only one line of symmetry? No. You can draw and check. A square has four line of symmetry like this. You can fold it like this, like this, like this or this and get all these four lines of symmetry. Take a square piece of paper by folding, find all its lines of symmetry. Here are different folds giving different lines of symmetry. Fold the paper into half vertically. Fold it again into half horizontally. That is, you have folded it twice. Now open out the folds. Vertical fold, horizontal fold. Again fold the square into half for a third time now, but this time along a diagonal, as shown in the picture. Again, open it. Fold it into half for the fourth time, but this time along the other diagonal, as shown in the figure. Open out the fold. You can see steps for making these folds. Is there any other way to fold the square so that the two halves overlap? How many lines of symmetry does the square shape have? A square has 4 lines of symmetry. Thus, figure can have multiple lines of symmetry. The figures below also have multiple lines of symmetry. Can you find them all? You can see this is a line of symmetry. This one is also a line of symmetry. 1 and 2. Then this one, third one, 3. Then 4. Then 5. Then 6. This figure has 6 lines of symmetry. Similarly, in this one, 1, 2, 3, 4, 5, 6. This figure has 6 lines of symmetry. Similarly, this figure has 1, 2, 3, 4 lines of symmetry. We saw that the diagonal of a square is also a line of symmetry. Let us take a rectangle that is not a square. Is its diagonal a line of symmetry? The answer is no. You can check here. This portion, when folded, doesn't overlap the other half along this line. So you can say in a rectangle, the diagonal is not a line of symmetry. First, see the rectangle and answer this question. Then take a rectangle piece of paper and check if the two parts overlap by folding it along its diagonal. What do you observe? Reflection. So far, we have been saying that when we fold a figure along a line of symmetry, the two parts overlap completely. We could also say that the part of the figure on one side of the line of symmetry is reflected by the line to the other side. Similarly, the part of the figure on the other side of the line of symmetry is reflected to the first side. Let us understand this by leveling some points on the figure. The figure shows a square with its corners leveled A, B, C and D. Let us first consider the vertical line of symmetry. When we reflect the square along this line, the points B, C on the right get reflected to the left side and occupy the position occupied earlier by AD. What happens to the points AD? A occupies the position occupied by B and D that of C. You can see when this vertical line is taken as line of symmetry, when folded, position of A is occupied by point B and position of point D is occupied by point C. What if we reflect along the diagonal from A to C? Where do points A, B, C and D go? What if we reflect along the horizontal line of symmetry? You can draw a diagonal like this and check by folding which point overlap the other. You will see this point C overlaps point A. A figure that has a line or lines of symmetry is thus also said to have reflection symmetry. Generating shapes having lines of symmetry. So far we have seen symmetrical figures and asymmetrical figures. How does one generate such symmetrical figures? Let us explore this. Ink blot devils. You enjoy doing this earlier in class 5. Take a piece of paper, fold it in half, open the paper and spill a few drops of ink or paint on the one half. Now press the half together and then open the paper again. What do you see? Is the resulting figure symmetric? If yes, where is the line of symmetry? Is there any other line along which it can be folded to produce two identical parts? Try making more such patterns. Paper folding and cutting. Here is another way of making symmetric shapes. In these two figures, a sheet of paper is folded and a cut is made along the dotted line shown. Draw a sketch of how the paper will look when unfolded. When paper is unfolded, you will see a hole of this shape. This will be a line of symmetry. You will see a blank here at the darkened portion because using a scissor this has been cut out. Do you see a line of symmetry in this figure? What is it? The line of symmetry is the line of fold. Make different symmetric shapes by folding and cutting. There are more ways of folding and cutting pieces of paper to get symmetric shapes. Use thin rectangular colored paper, fold it several times and create some intricate patterns by cutting the paper like the one shown here. Identify the lines of symmetry in the repeating design. Use such decorative paper cutouts for festive occasions like this. Figure it out. Punching game. The fold is a line of symmetry. Punch holes at different locations of a folded square sheet of paper using a punching machine and create different symmetric patterns like this. First you have to fold the paper, then you have to punch it and then unfold it. This will be line of symmetry. That is, the line of fold will be the line of symmetry. 1. In each of the following figures, a hole is punched in a folded square sheet of paper and then the paper was unfolded. Identify the line along which the paper was folded. Figure D was created by punching a single hole. How was the paper folded? In figure A, this will be the line of symmetry. In figure B, this will be the line of symmetry. In figure C, this will be the line of symmetry. Since figure D has been made using punching a single hole, it will have two folds. First, it is to be folded along vertical or horizontal line like this, then folding along this line such that its shape become the quarter of the what is present now like this, and punching is done at the corner like this, and when unfolded you will get this shape. To give the lines of symmetry, find the other holes. In figure A, the hole will be here. In figure B, here. In figure C, here. In figure D, here. And in figure E, here. 3. Here are some questions on paper cutting. Consider a vertical fold. We represent it this way. Vertical fold like this. Similarly, a horizontal fold is represented as follows. Horizontal fold like this. 4. After each of the following cuts, predict the shape of the hole when the paper is opened. After you have made your prediction, make the cutouts and verify your answer. A. If cut is made along this line, and when the paper will be unfolded, you will get a hole of this shape. This will be the hole. Similarly, you can try B, C, D. You can take paper like this and a scissor and cut out as shown here, and unfold the paper and get the shape. 5. Suppose you have to get each of these shapes with some folds and a single straight cut. How will you do it? A. The hole in the center is a square. B. The hole in the center is a square. You can see a square hole here and a rotated square hole here. Note, for the above two questions, check if the four-sided figures, the center satisfy both the properties of a square. For the first question, you have to take a square paper like this and then you have to fold it along its diagonals like this. For the first time along this line and then along this line, such that you get a shape of triangle like this. Then using scissor you have to cut this portion out, and when you unfold you will get this type of hole. And for the second question, you have to take a square paper like this. Then you have to fold it along its side, that is in vertical and then in horizontal direction, such that you get a quarter piece of paper like this, having two folds. One fold along this line and the other fold along this line. Then using scissor, you have to cut this portion out. And when you unfold it, you will get this shape. You can see here, this portion has been cut out from this quarter part. And in this, you can see this portion has been cut out in the 1/4 of the square, that is in this triangle. 6. How many lines of symmetry do these shapes have? 1. Two figures are given here. Let's draw lines of symmetry like this. Since it is a square, it has 4 lines of symmetry like this. Number of lines of symmetry is equal to 4. 1 in this one, 2, 3, similarly 4, 5, 6, 7, 8, and this figure has 8 lines of symmetry. 2. A triangle with equal sides and equal angles, that is an equilateral triangle. Its lines of symmetry will be 1, 2, and 3. It has 3 lines of symmetry. 3. A hexagon with equal sides and equal angles. Lines of symmetry 1, 2, 3, 4, 5, 6, 6 lines of symmetry. 7. Trace each figure and draw the lines of symmetry if any. Similarly, you can draw lines of symmetry in these figures. 8. Find the lines of symmetry for the column below. You can try doing it. 9. Draw the following. A. A triangle with exactly one line of symmetry. If you take an isosceles triangle like this, then it will have only one line of symmetry. In this triangle, these two sides are equal, so it is known as isosceles triangle. B. A triangle with exactly 3 lines of symmetry. For this, you can draw an equilateral triangle, that is a triangle whose all its side lengths are equal. Then you can draw lines of symmetry like this. It has three lines of symmetry. This is known as equilateral triangle. See a triangle with no lines of symmetry. For this, you have to draw a triangle such that whose no sides are equal. That is a scalene triangle. All sides are of different length. This triangle is known as a scalene triangle. It has no lines of symmetry. Is it possible to draw a triangle with exactly two lines of symmetry? The answer is no. You can try doing this. 10. Draw the following. In each case, the figure should contain at least one curved boundary. A. A figure with exactly one line of symmetry. You can draw a shape like this, having exactly one line of symmetry. B. A figure with exactly two lines of symmetry. For this, you can draw a shape like this. It has exactly two lines of symmetry. C. A figure with exactly four lines of symmetry. For this, you can draw a square with a circle passing through all its corners. It has four lines of symmetry, like this. Your answers could be different than mine. 11. Copy the following on squared paper. Complete them so that the blue line is a line of symmetry. Problem A has been done for you. You have to draw in such a way that the blue line become the line of symmetry. In figure B, you can draw like this. Similarly, in C, you can draw like this. Such that the blue line become a line of symmetry. Similarly, you can try doing D, E, F. Hint, for C and F, see if rotating the book helps. 12. Copy the following drawing on squared paper. Complete each one of them so that the resulting figure has the blue lines as lines of symmetry. You can do like this. Similarly, you can try doing others. 13. Copy the following on a dot grid. For each figure, draw two more lines to make a shape that has a line of symmetry. Please note that you have to draw only two lines, like this. For this one, you have to take dot grid of larger size. Similarly, you can try doing these. 9.2 Rotational Symmetry. The paper windmill in the picture looks symmetrical, but there is no line of symmetry. However you fold it, the two halves will not exactly overlap. On the other hand, if you rotate it by 90 degree about the red point at the center, the windmill looks exactly the same. We say that the windmill has rotational symmetry. If you look the windmill carefully, it has four equal parts. If you rotate in clockwise or anti-clockwise direction by 90 degree, you will get the same windmill without any change in orientation. When talking of rotational symmetry, there is always a fixed point about which the object is rotated. This fixed point is called the center of rotation. Will the windmill ever look exactly the same when rotated through an angle less than 90 degree? The answer is no. An angle through which a figure can be rotated to look exactly the same is called an angle of rotational symmetry, or just an angle of symmetry for short. For the windmill, the angles of symmetry are 90 degree, quarter turn, 180 degree, half turn, 270 degree, 3/4 turn, and 360 degree full turn. Observe that when any figure is rotated by 360 degree, it comes back to its original position, so 360 degree is always an angle of symmetry. Thus, we see that the windmill has four angles of symmetry. Do you know of any other shape that has exactly four angles of symmetry? For example, if you take a square, it has rotational as well as reflectional symmetry. Reflectional symmetry along its diagonals and horizontal and vertical line passing through the center of the square. It has reflectional symmetry along these lines and rotational symmetry of 90 degree, 180 degree, 270 degree and 360 degree. These angles are angles of symmetry. There are two things, lines of symmetry and angles of symmetry. Red lines are lines of symmetry as shown here, and blue angles are angles of symmetry. If a figure has lines of symmetry, then it is said to have reflectional symmetry. And if a figure has angles of symmetry other than 360 degree, then it can be said to have rotational symmetry. How many angles of symmetry does a square have? 4. 90 degree, 180 degree, 270 degree, 360 degree. How much rotation does it require to get the initial square? The answer is 360 degree. In fact, all objects return to its initial shape when rotated by 360 degree. We get a square overlapping with itself after 90 degree of rotation. This takes point A to the position of point B, point B to the position of point C, point C to the position of point D, and point D back to the position of point A. You can see here, this is imaginary reference line, line after rotation, initial position. This is square after rotation. If rotated in this direction, B occupies C, A occupies D, D occupies C, C occupies B. You can see the position of A, B, C and D in the second figure. A, B, C and D. Do you know where to mark the center of rotation? That is the center of square. What are the other angles of symmetry? 180 degree, 270 degree, 360 degree. You can see initial position and line after rotation by 180 degree, line after rotation by 270 degree and line after rotation by 360 degree. Example: find the angles of symmetry of the following strip. Solution: let us rotate the strip in clockwise direction about its center. It has been rotated by 180 degree. You can see it here. A rotation of 180 degree results in the figure above. Does this overlap with the original figure? No. Why? You can see here, this is not the same as this one. Another rotation about 180 degree from this position gives the original shape. If rotated by 180 degree, you will get the original shape again. This figure comes back to its original shape only after one complete rotation through 360 degree. So we see that this figure does not have rotational symmetry. Rotational symmetry of figures with radial arms like this. Consider this figure, a picture with 4 radial arms. How many angles of symmetry does it have? What are they? Note that the angle between adjacent central dotted lines is 90 degree. Angles of symmetry will be 90 degree, 180 degree, 270 degree and 360 degree. Can you change the angles between the radial arms so that the figure still has 4 angles of symmetry? Try drawing it. To check if the figure drawn indeed has 4 angles of symmetry, you could draw the figure on 2 different pieces of paper. Cut out the radial arms from one of the papers, keep the figure on the paper fixed, and rotate the cutout to check for rotational symmetry. How will you modify the figure above so that it has only 2 angles of symmetry? Here is one way. It has 2 angles of symmetry, that is 180 degree and 360 degree. We have seen figures having 4 and 2 angles of symmetry. Can we get a figure having exactly 3 angles of symmetry? Can you use radial arms for this? You can make shapes having 3 equal angles like this. Let us try with 3 radial arms in the figure below. How many angles of symmetry does it have and what are they? Here is a figure with 3 radial arms. If radial arms align themselves with having 120 degree in between, then they will have 3 angles of symmetry. Trace and cut out a copy of this figure. By rotating the cutout over this figure determine its angles of rotation. We see that only a full turn or a rotation of 360 degree will bring the figure back into itself. So this figure does not have rotational symmetry as 360 degree is its only angle of symmetry. However, can anything in this figure be changed to make it have three angles of symmetry? Can it be done by changing the angle between the dotted lines? If a figure with three radial arms should have rotational symmetry, then a rotated version of it should overlap with the original. Here are rough diagrams of both of them. If these two figures must overlap, what can you tell about the angles? You can see when rotated clockwise, A replaces B, B replaces C, C replaces A. You can see here. Since angle A becomes angle B becomes angle C, and angle C becomes angle A. You can say that angle A, angle B, angle C are equal. Then you have to split 360 degree, that is angle at the center or complete angle, in three parts. So each angle will be 120 degree. So angles of rotation will be 120 degree, 240 degree and 360 degree. Observe that angle A must overlap angle B must overlap angle C, and angle C must overlap angle A. So angle A is equal to angle B is equal to angle C. What must be this angle B? We know that a full turn has 360 degrees. This is equally distributed amongst these three angles. So each angle must be 360 degree divided by 3 is equal to 120 degree. So the radial arms figure with three arms shows rotational symmetry when the angle between the adjacent dotted lines is 120 degree. Use paper cutouts to verify this observation. Now, how many angles of rotation does the figure have and what are they? Initial position, after 120 degree rotation, after 240 degree, that is 120 plus 120 degree rotation, after 360 degree rotation, that is 120 degree plus 120 degree plus 120 degree. So angles of rotation will be 120 degree, 240 degree and 360 degree. Note, the color have been added to show the rotation. Let us explore more figures. Can you draw a figure with radial arms that has exactly 5 angles of symmetry? For this, you can draw a shape like star face or like a pentagon with all its sides equal. Angles of symmetry will be 360 degree divided by 5. Minimum angle of symmetry will be 72 and others multiple of 72. That is 72 degree, 144 degree, 216 degree, 288 degree and 360 degree. B. 6 angles of symmetry. For this, you can draw a hexagon like this. with all its sides equal, the angle subtended at the center by one side will be 60 degree. That is 360 degree divided by 6. Its angles of symmetry will be 60 degree, 120 degree, 180 degree, 240 degree, 300 degree and 360 degree. Also find the angles of symmetry in each case. I have already found out. Hint: use 5 radial arms for the first case. What should be the angle between two adjacent radial arms be? Consider a figure with radial arms having exactly 7 angles of symmetry. What will be its smallest angle of symmetry? Is the number of degrees a whole number in this case? If not, express it as a mixed fraction. If it has 7 angles of symmetry, then the minimum angle of symmetry will be 360 degree divided by 7. That will be (51 whole 3/7). Let us find the angles of symmetry for other kinds of figures. Figure it out. 1. Find the angles of symmetry for the given figures about the point marked dot. If this is taken as reference line, then angles of rotation will be, or angles of symmetry will be 90 degree, 180 degree, 270 degree and 360 degree. And for the figure B, there will be no angles of symmetry except 360 degree. For C, there will be two angles of symmetry, 180 degree and 360 degree. 2. Which of the following figures have more than one angle of symmetry? It has 4 angles of symmetry, that is 90 degree, 180 degree, 270 degree and 360 degree. Similarly, this figure has 3 angles of symmetry, 120 degree, 240 degree and 360 degree. Similarly, this one too. Similarly, this one has 4 angles of symmetry, that is multiple of 90 degree, and this too. You can see in this figure a pentagon at the center. So the angle made by one side will be 72 degree. So angles of symmetry will be multiple of 72 degree. That is 72 degree, 144 degree, 216 degree, 288 degree and 360 degree. This figure has no angles of symmetry except 360 degree. That means it has no rotational symmetry. 3. Give the order of rotational symmetry for each figure. For this one, 180 degree and 360 degree. For this one, 90 degree, 180 degree, 270 degree and 360 degree. For this one, multiple of 60 degree, that will be 60 degree, 120 degree, 180 degree, 240 degree, 300 degree and 360 degree. Or this figure, multiple of 120 degree, that is 120 degree, 240 degree and 360 degree. Similarly, for this one, it will have 4 angles of symmetry, multiple of 90 degree, and for the last one, angles of symmetry will be 72 degree, 144 degree, 216 degree, 288 degree and 360 degree. Let us list down the angles of symmetry for all the cases above. Angles of symmetry when there are exactly 2 of them, 180 degree and 360 degree. Angles of symmetry when there are exactly 3 of them, 120 degree, 240 degree, 360 degree. Angles of symmetry when there are exactly 4 of them, 90 degree, 180 degree, 270 degree, 360 degree. Do you observe something common about the angles of symmetries in these cases? The first set of numbers are all multiples of 180 degree. The second are all multiples of 120 degree. The third are all multiples of 90 degree. In each case, the angles are the multiples of smallest angle. You may wonder and ask if this will always happen. What do you think? Yes, this will be always true. True or false? Every figure will have 360 degrees as an angle of symmetry. It will be always true. If the smallest angle of symmetry of a figure is a natural number in degrees, then it is a factor of 360 degree. This is false. For example, if we take the smallest angle of symmetry to be 7 degree, for example, then you know that the number of angles of symmetry is a natural number. Since 360 degree divided by 7 is not a natural number, so this statement is false. Is there a smallest angle of symmetry for all figures? It turns out that this is the case for most figures, except for the most symmetric shapes like the circle, whose symmetries we now discuss. If we take a circle, then it will have infinite lines of symmetry and angles of symmetry. Symmetries of a circle. A circle is a fascinating figure. What happens when you rotate circle clockwise about its center? It coincides with itself. It does not matter what angle you rotate it by. So, for a circle, every angle is an angle of symmetry. Now, take a point on the rim of the circle and join it to the center. Extend the segment to a diameter of the circle. Is that diameter a line of reflection symmetry? It is. Every diameter is a line of symmetry. You can see, if you draw any line that is passing through the center, will be a line of symmetry. Like wheels, we can find other objects around us having rotational symmetry. Find them. Some of them are shown below. Fan, flower, wheel. Figure it out. 1. Color the sectors of the circle below so that the figure has 3 angles of symmetry. You can color it like this. Similarly, or the second one, 2, 4 angles of symmetry. You can color it like this. Three, what are the possible numbers of angles of symmetry you can obtain by coloring the sector in different ways? 2. Draw two figures other than a circle and a square that have both reflection symmetry and rotational symmetry. You can draw a rectangle that has reflection as well as rotational symmetry. Similarly, you can draw a hexagon like this, which has rotational as well as reflection symmetry. 3. Draw, wherever possible, a rough sketch of a triangle with at least 2 lines of symmetry and at least 2 angles of symmetry. You can draw an equilateral triangle. It will have more than 2 lines of symmetry and 2 angles of symmetry. B. A triangle with only one line of symmetry but not having rotational symmetry. For this, you can draw an isosceles triangle whose two sides are equal. It has a line of symmetry but no rotational symmetry. This is isosceles triangle. C. A quadrilateral with rotational symmetry but no reflection symmetry. For this, you can draw a parallelogram whose opposite sides are parallel and equal. It doesn't has any line of symmetry. You can see here. This portion has mirror image like this one. So you can say this blue line, that is the diagonal, is not a line of symmetry, though it has a rotational symmetry of 180 degree and 360 degree. D. A quadrilateral with reflection symmetry but not having rotational symmetry. For this, you can draw an isosceles trapezium like this, whose two sides are equal and other two sides are parallel. It has reflection symmetry but no rotational symmetry. This is a parallelogram, and this one isosceles trapezium. 4. In a figure, 60 degree is a smaller angle of symmetry. What are the other angles of symmetry of this figure? That will be multiple of 60 degree. Five. In a figure, 60 degree is an angle of symmetry. The figure has two angles of symmetry less than 60. What is its smallest angle of symmetry? Factors of 60 degree, 30 degree, 15 degree, 10 degree, and so on. Since it is said it has two angles of symmetry less than 60 degree, so the smallest one will be 15 degree. The answer is 15 degree. 6. Can we have a figure with rotational symmetry whose smallest angle of symmetry is A 45 degree, B 17 degree? This one is possible as 360 degree is completely divisible by 45 degree, but this is not possible as 360 degree is not completely divisible by 17 degree. For 45 degree, yes, and for 17 degree, no. In other words, you can say in the multiple of 45 degree, we get 360 degree. But in the multiple of 17 degree, we doesn't get 360 degree. 7. This is a picture of the new parliament building in Delhi. A. Does the outer boundary of the picture have reflection symmetry? If so, draw the lines of symmetries. How many are they? One line of symmetry like this, 2 and 3. The answer is it has 3 lines of symmetry. B. Does it have rotational symmetry around its center? B. Does it have rotational symmetry around its center? If so, find the angles of rotational symmetry. 120 degree, 240 degree, and 360 degree. Eight. How many lines of symmetry do the shapes in the first shape sequence in Chapter 1, Table 3, the regular polygons have? What number sequence do you get? 9. How many angles of symmetry do the shapes in the first shape sequence in Chapter 1, Table 3, the regular polygons have? What number sequence do you get? 10. How many lines of symmetry do the shapes in the last shape sequence in Chapter 1, Table 3, the coach snowflake sequence have? How many angles of symmetry? 11. How many lines of symmetry and angles of symmetry does Ashok Chakra have? You can see two spokes make one line of symmetry. Similarly, there are 24 spokes, that means 24 divided by 2 equal to 12 lines of symmetry. Similarly, 360 degree, that is a complete angle, have been divided by 24 spokes. So smallest angle of symmetry will be 15 degree and others will be multiple of 15 degree up to 360 degree. 14. Playing with tiles. A. Use the color tiles given at the end of the book to complete the following figure so that it has exactly 2 lines of symmetry. B. Use 16 such tiles to make figures that have exactly 1 line of symmetry, 2 lines of symmetry. C. Use these lines in making creative symmetric designs. You can see tiles here. Game. Draw 6 by 6 grid. Two players take turns covering two adjacent squares by drawing a line like this. The line can be placed either way, horizontally or vertically. The lines cannot overlap. The game goes on till a player is not able to place any more lines. The player who is not able to place a line loses. With what strategy can one play to win this game? Please note that this is not allowed. Summary. When a figure is made up of parts that repeat in a definite pattern, we say that the figure has symmetry. We say that such a figure is symmetrical. A line that cuts a plane figure into two parts that exactly overlap when folded along that line is called a line of symmetry or axis of symmetry of the figure. A figure may have multiple lines of symmetry. Sometimes a figure looks exactly the same when it is rotated by an angle about a fixed point. Such an angle is called an angle of symmetry of the figure. A figure that has an angle of symmetry strictly between 0 and 360 degrees is said to have rotational symmetry. The point of the figure about which the rotation occurs is called the center of rotation. A figure may have multiple angles of symmetry. Some figures may have a line of symmetry but no angle of symmetry, while others may have angles of symmetry but no lines of symmetry. Some figures may have both lines of symmetry as well as angles of symmetry. For more videos, you can subscribe NCERT video. Thank you.